Okay, so our next speaker, really, especially in this audience, doesn't need much of an introduction. This is our invited talk for the morning session by Susan McGregor, who's going to be talking about learning from low-tech pets. So this will be about a half hour, then some time for Q&A, and then we'll break for our lunch and virtual ice cream. So those of you that are...
Wait, ice cream is virtual?
Sorry, I shouldn't have said that quite that way. Ice cream is not virtual if you are here. Ice cream is very real and concrete if you are here. I was more saying that to encourage the gather people not to vanish as soon as Susan is done speaking. So, without further ado, take it away, Susan.
Hey, thank you so much. I appreciate the interest in real ice cream. I was also going to say that feels like a bait and switch otherwise. So hi everyone, my name is Susan McGregor. I'm an associate research scholar at the Data Science Institute at Columbia University. And today I was really torn about kind of what to present today. I'm sorry that I can't be in Australia with all of you. I definitely pondered, or with so many of you, I definitely pondered the opportunity. But as I went back and forth on topics, I really wanted to come back to something that actually I have been thinking about since I got involved in privacy and security about 10 years ago. And that was doing what I do in the rest of my work, which is sort of thinking about communities and how communities interact with security and privacy technologies. So the reason why I chose learning from low-tech pets is because over the years I've come across a lot of examples of different ways in which communities and individuals have taken steps to protect their privacy and security. And I want to be clear here that when I talk about this, a lot of the principles that I am going to address, I think, do inform a lot of the privacy-enhancing technologies that communities like this are building. But I still think that there's more that we can learn from them, and so that's kind of what I wanted to address today. So when I say low-tech pets, I don't necessarily mean privacy-enhancing technologies that are not complicated, right? Because I think an interesting thing about quote-unquote low-tech pets is that very often they are complicated and they actually take kind of quite a bit of effort to use. What I really mean in this case is not using digital computers. And so what I'm going to do is just kind of take you through some examples of types of low-tech privacy-enhancing technologies that have existed throughout history, and then kind of reflect on what we might take away from thinking about these as designers of contemporary privacy-enhancing technologies. And maybe some directions for kind of research and development that this might inspire. So, So I think one thing that I also want to highlight here is that, you know, privacy, as we all know, is a complex idea, right? And it doesn't mean the same thing to everyone. It doesn't mean the same thing to even the same person, often depending on their context or situation. But one thing I think we do know is that privacy is not necessarily about secrecy, but it is about control, right? A lot of the privacy-enhancing technologies that many of us work on and are interested in are specifically about protecting the ability to share information, but being able to control who it's shared with and how. And so I want to kind of sort of put a point on that right now. And also to think about the fact that in many cases, and obviously this is the case in most internet-based sort of network technologies, privacy is also not necessarily about being free from observation, right? So depending on where you are, I'm located in the United States, there are notions of privacy that have to do with not being watched, right? Not being seen by others. And really historically, that's a very unusual circumstance for people. In most cases in history, in human society, having actual privacy, having the kind of privacy where you were actually not observed by other humans is pretty rare. So in most cases, the kinds of like low-tech or community-driven privacy-enhancing technologies that I'm thinking of have to do with being able to have control over information even when you are being observed by other people. And I think another thing that sort of emerges for me in thinking about these examples is actually the importance of destruction. So this is something that's sort of a perennial issue, and I would argue kind of a key aspect of a lot of privacy-enhancing technologies outside of digital computing, is the ability to destroy. And that's not something that, in the case of in the case of digital technologies, is frankly really feasible for most people to do. And I'm going to argue that that's a problem, and it's a problem that we should work on. Okay, so now for, I think, sort of the fun stuff, which is just talking about examples of low-tech pets throughout history and kind of the strategies that they employ. So again, these strategies are not going to be things that are a surprise to probably anyone in this room, right? These are common techniques that are used all the time in digital and networked pets. But again, I just kind of want to lay them out here for clarity. So obfuscation, right, in which we disguise the existence of information, or sometimes the mechanism of accessing it. What I'm calling physical ciphers, which are essentially unique locking mechanisms, which in many cases are going to serve both to protect information, data, artifacts, whatever, but also kind of serve as an authentication mechanism in many instances. Content ciphers, again, not a unique idea or an unusual idea here, but particularly when we're talking about sort of community-driven or low-tech pets, we're usually talking about often a kind of social steganography, right? So a case where rather than sort of, there are cases where we see messages are physically obfuscated, but also where the meaning of something is hidden because the sort of key to it is a kind of out-of-band social knowledge, right? That allows the people reading the message to be able to or unable to correctly interpret the content that they're seeing. And again, of course, strategic destruction. And what destruction looks like, depending on the particular technology in question, will be different. In some cases, this is going to be really basic, like let's burn it all down kind of things, or let's burn specific items down. But for example, when we're talking about social steganography, it could also be the evolution, for example, of a meme. So it could be something where the context or meaning of something is tweaked or adjusted in such a way that it no longer means what it used to mean, and so there comes this sort of in-group, out-group function of whether an outsider is up to date enough, essentially, to correctly interpret a coded message. So some of the fun examples, I don't know, I think they're fun, of obfuscation. So each of these is an example of what I consider a different type of obfuscation. So on the left, we have a Japanese puzzle box. This is a really fascinating practice that originated in sort of the late 19th century with a few master craftsmen in Japan. And it's thought that one of the original purposes of these boxes was actually to hide tools. And you may have seen things like this. They're still sort of popular in novelty shops. There remains one last living master puzzle box maker today. This sort of reached a peak around World War II, and it's been apparently very difficult to find apprentices since. But the puzzle boxes, this is an example of a seven-step puzzle box. You can imagine this box, if not for kind of the elaborate decoration, it would be hard to know that there was actually supposed to be something in here, which is why I kind of put this in obfuscation, even though it fits into a couple of categories. But they, actually, the currently living craftsman has made up to 102 step boxes. And so different parts of the box shift and slide in different directions. And in order to successfully open the box, you need to know not just the direction, but the order of the steps that need to be completed. The sort of middle picture here is a much more kind of quotidian example. This is, I think, not super uncommon in sort of like suburban areas. You want to, someone is coming to visit or staying at your house while you're away. They're coming to check on your plants or your pets. and your furry pets, perhaps. The idea is that this is a stone. This looks like a stone, but it is in fact, a fake, and inside of it is a key. And the farthest right example is actually a project that I did about, I don't know, sort of 10 or more years ago. My primary background is in journalism, and this was shortly after the Snowden leaks, and there was an incident where Glenn Greenwald, who sort of broke the Snowden story, his partner was traveling through, I believe it was Heathrow. He was traveling through the airport, and airport security recognized who he was, and he was carrying hard drives with him, and they confiscated the drives. And it got me thinking, what if they didn't know that he was carrying any data? And at the time I was traveling a lot, and I chose, and depending on your context, this style of necklace that had sort of these big rhinestones was very, very popular at the time. It was kind of everywhere. And I thought, that's big enough to hide something in. And so I actually made a piece of jewelry that I wore through an international airport that obfuscated, in this case, just a small USB drive, right? And so the idea that I wanted to play with there was the fact that, I could protect that data if it wasn't recognizable as digital data, right? It would not, if no one thought to look, then it couldn't be invaded. So those are kind of like my examples of obfuscation in low-tech pets. Physical ciphers. So these are some really fun examples, in my opinion. On the left, we have an example which is a number of years ago, researchers discovered a whole host of what they call locked letters. And so this is an evolution of, especially sort of in the, when paper was very, very expensive, it was not at all typical to actually put things in an envelope, right? And so we think about, so at least, when I do, education about privacy and security, right? We talk a lot about envelopes and protecting things, and the sort of mail, for me, the mail metaphor is one that I go to frequently. But that was actually really uncommon because paper was extremely expensive. It was also very strong because it was parchment in many cases. And so in this example, and there's a wonderful video, set of links in the slides that I can share, that demonstrates one famous example is Mary Queen of Scots, on the eve of her execution, wrote a letter to her brother, in which she describes the fact that she's been informed that she's going to be executed the next morning. And it shows the way in which she essentially cuts a small slice of paper from the inside fold of her letter and uses it to thread through in such a way that in order to open the letter, that strip of paper would need to be broken. And so it would both kind of authenticate the contents of the letter to demonstrate that it hadn't been opened or read in transit, but also served as kind of a physical cipher. If you didn't know how to do it or you didn't know how to undo it, you might not successfully get to the contents. The one on the right, the example on the right, this is from a YouTube channel that I imagine many of you may be familiar with, called The Lockpicking Lawyer. This was an interesting one that he posted that initially he didn't know the purpose of. This is a bookmaker's lock. And so the purpose of this device is actually to record the last time that it was opened. And so the mechanism itself is not particularly complex, but the important thing about it is that it essentially timestamps it. And of course, because if you were to open the lock to get at presumably the bag or box of betting slips, you could place a bet after the fact. And so it serves as an authentication mechanism that the betting has not been tampered with by registering the last time that the lock was opened. So those are some examples of what I would call physical ciphers of a kind. I think one that's always really fascinated me, and that I always come back to when I think about arguments that are commonly made against people's or communities' apparent disinterest in privacy, and that is the use of slang or community lexicons for communicating. So there's a few different examples here. One on the left, again, some of you may be familiar with, this is the so-called Rogues Lexicon, which was compiled by George W. Matzel. He is most famous for being the first police commissioner of New York City. And at the time that the NYPD was essentially founded, it was very common, and there are many examples in many communities, obviously, of this kind of thing, where essentially the thieves, the criminals of New York, used a kind of lexicon that was intentionally coded, so that someone who wasn't in on it, overhearing their conversations, would not have any idea, any real creditable idea of what they were talking about. And so one of Matzel's innovations was to actually compile, to make an organized effort to actually compile the contents of that lexicon and publish them to essentially break the code for what would become New York's first police force. And again, some of these examples may well be familiar to folks here. I think many of us are familiar with examples of censorship-resistant strategies using, again, lexicons, especially in surveilled communications. So the use of homophones and emoji to talk about taboo ideas in surveilled chat systems and things like that. And then the one on the lower right is an example, a sort of recently uncovered example of a cipher. It's attributed to Catherine of Aragon, who was Henry VIII's first wife, in which a scholar recently sort of decoded the message that suggesting that this was a design for a piece of jewelry in which she essentially declared herself the true Queen of England, even though she had been overthrown for her sister, Anne Boleyn. And again, an example where there's sort of like a kind of steganography there of interlocking letters and patterns that are used to convey meaning that only recently sort of has been revealed by modern scholars. Again, probably was quite transparent to people, certain communities at the time. And then the last sort of set of examples is just destruction. So the thing about low-tech pets is that destruction isn't usually that complicated. It's something that almost anyone can undertake without a lot of difficulty. Burn it, shred it, smash it, whatever it is that you want to do, melt it. But I think a really key feature is the ability for people without special skills to destroy information that they want to get rid of. As I say, I think that that's actually a much more important part of thinking about, it is to me an increasingly important part of thinking about privacy-enhancing technologies that are responsive to the needs and interests and abilities of sort of large communities. So what can we take away from this? In thinking about why low-tech pets work in particular ways, for obfuscation, one of the key features for low-tech pets is that physical access is required, right? And this is, again, not an unknown scenario in digital privacy-enhancing technologies, right? Where we create situations where physical access is required to a device in order to access the data that it contains. And so there's a limit to resources, right? So a human being can only try so many combinations on a Japanese puzzle box, right, in a finite amount of time. Someone who's looking to find a key to break into a house only will probably have a certain amount of time that they can, look for the special stone before they're observed, right, or raise suspicions. And so the reason why it works is the reason why we can do obfuscation, certain types of obfuscation with digital data, which is that it requires some kind of access to the device and the ability to, and is sort of time constrained in the kinds of attacks that can be executed. But why doesn't this work as well with digital pets? Well, very few devices are truly offline. I remember many years ago, actually, at Usenix Security, there was a panel talk or something about the security risks of IoT, and a very a question I raised at the time, which there was not particularly an answer to, and I think there's even less of an answer to now, is we just can't get stuff that isn't on the internet, right? It's more and more difficult to find just to find unconnected devices, right? And this is a real problem. I think we all kind of recognize that. But I think thinking about that strategically as a limitation for current digital pets and like how do we do something about that, I think bears reflection. Physical ciphers. So physical ciphers in a low-tech scenario work because in general, there are a lot of people who have the skills to customize the functioning of a lock or a box or what have you, right? So if I want to secure my home, I can put, 3 different locks and a deadbolt and a floor bolt and a chain and whatever, over my door to make sure that people can't get in, right? To protect whatever it is. I have the skills to do that. I have the right to do that. In many cases with digital technologies, one aspect of it is that the vast majority of digital devices are mass produced. And it's either very difficult, you need really specialized skills and tools, or it is illegal to customize them in any meaningful way. So, I live in New York State. New York State just this year passed a right to repair law, which obviously applies to digital technologies, and that's sort of a step forward. But the reality is that in many cases, regular people, we're all kind of locked into the devices that are handed to us or made available to us, and that's really limiting when we think about, again, what individuals or communities might want or need out of privacy-enhancing technology. Content ciphers are effective because natural language and communication are constantly evolving. It's just what humans do. But also because in most cases, when we communicate with other people, we have multiple channels of communication, right? So we have multiple spaces where we interact with the same people or communities, which makes it possible to co-construct meaning and also to adapt and evolve that meaning if we need to. When it comes to kind of natural mechanisms for protecting privacy, I think the main thing that I think of is things like biometrics, which we all know are deeply problematic to use as, sort of authentication, authentication devices. And while we have made some progress in terms of multi-factor authentication and things like that, I think thinking creatively about how we can introduce more channels into privacy-enhancing technologies is, again, just something that I think is kind of interesting to think about. And then finally, strategic destruction. Again, I think this is really important. When it comes to low-tech stuff, I can always burn that letter you sent me. I can always destroy something I've been given. And when it comes to digital technologies, this is pretty much what we've got, right? If anyone recognizes this, this is a scene from the movie Office Space, where the office inhabitants, deeply frustrated with the behavior of their printer, take it out to a field and bash it up with a baseball bat. But as probably most people here are aware, we don't have a way to selectively destroy digital data, and it's a real problem. And I guess what I'm saying is I think it's a real problem. Okay, so what next? So these are just some ideas that I came up with in thinking about this, and I am excited to hear what others think. I think one thing that I take away from thinking about these examples is that it makes sense to try to take things offline. We see some of this with the evolution of physical security keys, for authentication, used as a multi-factor solution. But I wonder if we can't get a little bit more creative with this. How can we think about ways to take more data offline more of the time in such a way that it is just harder to attack? And again, I think that this is, I think that what I would say is there are, I think, a lot of norms that we work, there's a framework that we work within or we think through when we think about digital technologies and digital technologies for privacy that don't necessarily apply to most people. In other words, what I'm trying to do here is say, let's think outside what digital technologies do and think instead about what people do when they want to protect data and what they're willing to do to protect data and information, and try to use that as our inspiration for thinking about even digital technologies. Changing the form factor, mostly we use touchscreens, number pads, keyboards. Like, can we do something other than that, right? Can we think of different ways of interfacing? Actually, one of the examples I meant to give for the so-called physical ciphers is one from my personal history. So I grew up in New York City, and at the time that I was growing up, car theft was extremely common. Now apparently it's catalytic converters. Fortunately, I don't have a car. And after some number of years, and my family had multiple not nice cars stolen from outside of our house. And our eventual solution was to have our mechanic install something called an ignition cutoff, which was just an interrupt on the electric ignition mechanism in the vehicles. And we had one sort of relatively modern car where this was just a switch under the steering column. It was very small. You couldn't see it. You had to really just know that it was there and feel around for it. And that was the way that you would then, if you tried to start the car without that or even hotwire it, without flipping that switch, nothing would happen. My favorite thing about it is that when my grandmother passed away, we inherited her car, which was a 1989 Oldsmobile 98 model, which was a huge, huge car, did not even have power steering. And there was no way to put an ignition cutoff of the kind we had in the more modern vehicle into that car. And so instead, the ignition cutoff was wired to the radio and the brights. And so if you got in this car and you did not first power on the radio and flip on the brights, you would not be able to start the car, right? So this is an example of taking, a known interface with a known vulnerability and finding a different way to interact with it. Also, I think just leveraging actual human behavior. So I mentioned this before, like there are things that people are willing to do, that they're happy to do, that may or may not jive with the natural or easy affordances of digital technologies. And so I think if we're willing to kind of start there and work through those needs and those desires, then we will be able to come up with more creative and unique solutions that are solving more sort of real problems for real people. And finally, and I know this is a tricky one, we need to make it so that we can delete stuff or destroy stuff selectively or something, right? Because right now that inability is really hampering individuals' abilities to control their information, right? In preparation for this talk, I was rereading a paper by Dana Boyd about the way that teens in the US use social media. And some of you may have heard of this strategy, but she talked to a pair of women who talked about their different strategies, which was basically one of them would just delete their account any time that they weren't actively online. So as far as it appeared to anyone else, her account simply didn't exist unless she was literally online reading messages. And so again, we do have technologies that allow for that kind of deletion, but it's not in control of, it's only available to users when the developer has made it available, as opposed to being accessible to the individual and something that really anyone can do. And this goes for basic stuff like hard drives and thumb drives, things like that. And again, I know that there are some efforts out there at this, but I think it would be interesting to try to pursue that a little bit further. And that is all. I don't know if there are any questions. I'd love to hear ideas, et cetera, et cetera. So thanks so much for your time and attention, and I will turn off my screen now.
Okay. very much for the talk, Susan. I particularly liked the story about pork knocking on an Oldsmobile. I've never heard of that.